Hello, my name is Francesco, and now I'm going to describe my contribution and the code of Assessment 1, Project 1. So, essentially what we learned in class is how to build a spinning donut, and based on the spinning donut code from the book and the class explanation, we built essentially a spinning sphere by modifying some of the code. And essentially, this was we each modified one line of code, and this is the line of code that I modified in order to achieve the spinning sphere. So I will show it running right now, and as we can see, we see the sphere spinning around in a similar fashion to how the donut spun. And it keeps spinning forever. So yes, this is the overall code. Since I only contributed a line, I think I should mention a couple of the things that we see here. So we have the class and method setup. We have the initialization of all these values. We have even the brightness here, which stores all these characters. I have the rotation angles, the sphere size, the parameters for projection, and then we have the rendering resolution. The main loop, the reason why we see it going forever is because of this. Then we initialize the buffers. Then we have the for loops here, which do the sphere rendering. And then we have the projection to 2D. Now we have the screen mapping. Screen mapping right here. And then we calculate the luminance. Then we do the depth and brightness buffers, these if loops, and finally the display. So this pretty much prints out the character buffers to display the sphere that I just showed previously. It rotates the sphere by updating points A and B. Those are here. And then, well, this is just a short pause to control the speed of the animation. So now going to part 2 of the explanation. I just went through part 1. I highlighted the code that I presented previously, and everything is, the code from the book is highlighted in blue, and in order to make this work we used a lot of the code from the book. We just modified a couple lines. And so highlighted in red we see the code from my partners, and highlighted in yellow we see my code. And essentially what my line of code does is to calculate the depth of z position of a point essentially on the sphere, and how it does that is by adding a constant offset k2 to the vertical position of the point, and that is determined by the sphere radius, which is r1, and cos theta, of course, is the angle. And yeah, that's essentially what my contribution to the code does, this slide specifically. And yes, I think that would be all. Thank you.